x1 squared plus x2 squared minus 6 plus y squared equals 0, right? But as you can see, in case 2, y equals 0. But over here, negative 6 plus 0 equals 0. It doesn't make sense, right? So there's a contradiction. Okay? So there is a contradiction, which means that this kind of case doesn't work. Okay? Are you following? So one more time. In case 2, y equals 0.可以吗？刚才第二个情况就是 y 等于0。这样解出来之后，你会发现，好，到这边，就是它有在 case 2里面又要分两种情况。第一种情况是2加2 lambda 等于0 ，OK。When 2 plus 2 lambda equals 0, lambda equals negative 1. But in this situation, x1 and x2 they will both become 0. And if we plug in equation 4, we see that 0 plus 0 minus 6 plus y squared equals 0. But y squared should also be 0. So there's a contradiction, 对不对？因为负6再加上 y 平方 ，y 我们刚刚已经说在这里 y 应该要是0，负6加0就不会是0啊 ，OK？ 所以这边是有一个那个矛盾的情况，所以代表这个 case 是不 work，OK？So it's bad, okay? And then let's see case 2.2, okay? So case 2.2, we have x1 squared minus x2 squared equals 0, okay? And then x1 equals x2 or x1 equals negative x2, okay? Yep, I think this is fine. So, if you plug in, I think you can just perform the calculation by yourself. 我想这个你们大家自己一看也就可以解出来 ，OK？ So, in this way, finally, the answer is like this, okay? So, yeah, finally, it's either x1 equals x2 equals this, or okay, so yeah, basically we can have the 4 solutions in this case. Either x1 or both x1 and x2 equals square root of 3, or both negative square root of 3, and 1 positive, 1 negative. Okay, so we have the 4 cases, and then I mean the 4 solutions, and then you can just take a look. Is it alright? Yeah, I think this is alright. Okay, yeah. And over here you can also compare. Oh, let's see whether in this case the constraint is active or not. Case 2, y equals 0. I think directly when you see y equals 0, it just means that this becomes 0 sign. Okay, so yeah, in this case the constraint is active. Okay, so y the constraint is active. Okay, yep. So we have found several points. Okay, over here in case 1 we have found both x1 and x2 are zeros. Okay. 就是在第一个 case 里面，我们有得到一组解，就是 x1 x2 都是0 ，OK。And in this case, f of x1, x2 is 0, right? And over here we have 4 solutions. In case 2, we can have 4 solutions, and you will see that basically, yeah. the first two cases will result in the best solutions. I mean, f is the smallest for the first two cases, right? Yeah, let's see the first case. Okay, so f of x1, x2 is what? It's 3 plus 3 minus 3 times 3, okay? Negative 3, okay, so that's f. And for the second case, that's basically the same thing, okay? For the other ones, it's not that good, right? 如果是第三跟第四种情况下，它的那个 f 值不会这么小啊，反正会比这负3还大。Yep. So basically, you know, yeah, the two points are finally the minimum points in for this problem. Okay. Yep. Any question? So I guess you may find it very tedious, but don't worry. This kind of like hand calculation only happens for during the first month of our class. Okay. 可以吗？就是我们在刚开始第一个月才会比较需要这样。Because later on we will focus more on numerical solutions. And you may ask, then why do we need to do this? You know, the thing is, without some hand calculation, it is hard to learn the spirit of this kind of calculation, right? You have to try this by hand first. It's just like learning a language, right? When you learn a language, then you also need to learn like how to write. It's also the problem for modern day people. Nowadays, we just type without handwriting, and then it's actually very easy for us to forget how to write things down, right? Okay, yeah. Just like in language learning, it's also important to do some handwriting. Okay, so any question? So this is the first method for solving an optimization problem with inequality constraint. Okay? Yes. Okay. So yeah. What time is it now? Okay, yeah, we still have time. Okay. Let's see. Okay. So, can we continue with method 2? Yeah. So that was method 1, right? Transformation method. Okay, so method 2. So method 2 is about using the so-called KKT conditions. Okay. Do I spell this correctly? KKT conditions. Okay, but actually, the KKT conditions are pretty similar to the first method. Okay, yeah. Let me just write it down, and you will see. Yeah, hopefully, you can see why it is very similar to the first method we have learned. Okay. Oh, by the way, some people would just say the KT conditions because, yeah, the first two people, yeah, they both have their last name both starts both start with k. So some people will say, yeah, the so-called KT conditions. But I still prefer saying KKT conditions, right? Because, if someone contributes to the whole development of the theories, we should acknowledge that, right? We should remember this person, okay? So not just KT, I still prefer saying KKT, okay? Okay, so anyways, let's see. So for the same kind of problem, okay? Do I need to? Maybe I should still write this down one more time. Okay, so the problem is find. Okay, so the problem is to find x equals a set of variables. Okay, find x to minimize. To minimize function f of x subject to the constraints g sub j less than or equal to 0, j from 1 up to m. Okay, so this is the problem we are trying to solve. Okay, and method 2 is using KKT conditions. And again, it's very similar to what we have done. But over here, let's just directly write down the KKT conditions. So the first is I hope you guys are okay with I and j. Okay, so over here we have j constraints. Okay, so it's lambda j g j, the summation from 1 to m. But over here we have m equations because there are over here we totally have n equations because there are n variables for x. Okay, so that's the first part. Okay, and then of course, j from 1 to m. So 1 to m. And of course, j, always j is from 1 up to m. Okay, j is from 1 up to n. Okay, so all these are the so-called KKT conditions. G sub j. And as I said, basically, the KKT conditions are, they are almost like equivalent to the first method we have learned. Okay, let's see whether this is true or not. Okay.好，我再说一次，就是我刚刚已经说了 KKT condition， 你可以用刚才的第一种方式来理解，因为基本上是差不多同样的事情。OK， so first of all, maybe you have the question, really? Are they really the same? Because in our first method, over here, the partial derivative, we take the partial derivative for capital G, not small letter g. Right? Maybe you have the question， 可以吗？有可能同学会问，刚才我们学到的是把这边要对大 G 微分，这边对小 G 微分，所以应该不一样。But remember, what's the difference between capital G and lowercase g? The only difference is like over here, right? And because y or y squared is not related to x, so over here, when I take the partial derivative with respect to x, it doesn't matter whether I use uppercase g or lowercase g, right? 因为大 G 跟小 G 它的差异就只是在有加这个 y， 那不管有没有这个 y， 因为反正对 x 做偏微分的时候，有没有 y 其实都一样，所以 okay, so that's why over here even if this is lowercase g, it's still equivalent to the previous method we have learned, okay? And then you may also ask, okay, for this kind of equation, lambda g equals 0, but over here, this is what we have. We have lambda y equals 0, so they are still different, right? 可以吗？第二个问题就是 KKT condition 里面，这里写的是 lambda g 等于0，但是刚才学到的这个方式是写 lambda y 等于0，它们一样吗？ Are they the same? Are they basically saying the same thing? Lambda y equals 0, and over here lambda g equals 0. Are they basically the same thing? I think I should let you guys think first. Okay, so although previously we wrote 2 lambda y equals 0, or we can just write lambda y equals 0, right? So let me write over here, yeah. So yeah, let me write over here. 2 lambda y equals 0 is equivalent to lambda y equals 0, right? And lambda y equals 0 is equivalent to lambda y squared equals 0, right? Because we can multiply by y on both sides, right? So it's equivalent to lambda y squared equals 0. And what is y squared? Y squared is what? It's just negative small g, right? OK, 可以看出来吗 ？y 平方其实就是负的小 g, right? Yeah. This is g. Yeah. Over here, this is g. Okay. Capital G is that. So y squared is just negative lowercase g. So when you see that, of course, yeah. So that's the same thing. Okay. So lambda g equals 0 is equivalent to that. Okay. Yeah. And how about this? Yeah, this is like, of course, right? G sub j less than 0. Yeah. That's the original inequality constraint. So of course, yeah, we need to satisfy the inequality constraints. Okay. And finally, lambda sub j is larger than or equal to 0. This kind of condition, this condition did not appear previously. Okay, this is something new. Okay, and actually it's pretty important. And you can prove this. You can prove that lambda is non-negative using several different ways. Okay, but it may be very time-consuming. Yeah, let me think. Okay, let's see whether we have time for explaining this. Okay, at least I think later on I can explain why this is true using a simplified case. Okay. Yeah. But if you want to have a more strict proof, then you may need to consult the textbooks. Okay. So any question? So this is the so-called using KKT conditions. Okay. Altogether, they are the KKT conditions, and again, they are basically equivalent to the previous methods we have learned. Okay, yeah, because I just showed you that the first equation, yeah, that's the same thing, and then 2 lambda y is equivalent to lambda g. Okay, and g, of course, g needs to be less than or equal to 0. So the only thing new is this one. Okay, the last one, lambda j's must be non-negative. Okay, and yeah. If we have time, we can. I think either near the end of today's class or next week, I can talk about this, like why lambda j's are non-negative. 可以吗？就是我想，我刚刚说我们今天先把一些例子讲完，让大家可以有就是比较可以好好来写作业。那一些更理论的一些，为什么这个大于等于零，这个看今天有没有时间，或者最晚下一次可以讲。OK，Yeah，Yes。 Any question so far? Are you alright? Okay. You don't look very happy. I hope you guys can look happier. Okay. You know, okay. When I was a student, sometimes I wasn't able to understand what's going on in the class. Okay, but sometimes it's not because the material is hard. It's just because sometimes I just forget like what the abbreviated terms mean, right? For example, if you do not know S dot T dot, if you do not know what this means, then it might be harder to understand, right? So I hope that you guys remember S dot T dot just means subject to or such that, okay? Yeah. And over here I also try to like write things down like in a systematic way. I hope, and I hope that it's easier to understand. Okay, but if you have any other question, you can just let me know. Okay. Yeah. Okay, so again, let's take a break, and we will continue after the break.